Looking at notes 10-4, solve radical equations. So the steps for solving a radical equation are as follows. Number 1, get the radical by itself. In other words, isolate the radical. Number 2, raise both sides of the equation to the power of the index of the radical. Number 3, simplify and solve. And number 4, check your solution or solutions. So let's get started with some examples. The directions are to solve. So in number 1, we have fifth root of the quantity x plus 1 minus 6 equals negative 4. Okay, so remember, get the radical by itself, or in other words, isolate the radical. So this is the chunk that's in the radical. I need to get rid of the minus 6. So therefore, of course, I will add 6 to both sides. So when I add 6 to both sides, I get fifth root of x plus 1 equals, this would become positive 2. So then, of course, to get rid of the fifth root, I'm going to rewrite this, and I'm going to raise both sides of the equation to the power of the index of the radical. So the index is 5, so I'll raise both sides to the fifth power. So here, of course, the fifth root raised to the fifth power, those are going to cancel, and I'm going to be stuck with x plus 1 equals 2 to the fifth is 32. So then, of course, I will minus 1 both sides, and I will end up with x equals 31. And of course, I want to check before I box this completely, because I might need to put an ext in here for extraneous. So I'm going to check this mentally. So I'm going to plug in 31 where I see x. So 31 plus 1 is 32. The fifth root of 32 is going to be 2. 2 minus 6 is in fact equal to negative 4. So this is not an extraneous solution. It is a true solution. Okay, let's look at number 2. So here, again, I need to isolate my radical. So first, I'm going to minus 7. I have 2 fourth root of x equals, this is going to be 6. Okay, and then of course I'm going to divide both sides by 2. This is 1. So since this is fourth root of x equals 3, I'm not going to rewrite this time because I'm going to show you in a different color. Raise both sides to the power of the index, so that's 4. So I have x here equals 3 to the fourth power is 3 times 3 times 3 times 3, and that would give me 81. So again, before I box this, I'm going to check it mentally. So 81 goes in here. And again, if I take the fourth root of 81, that's going to be 3. So 3 times 2 is 6. 6 plus 7 is in fact 13. So this is a true solution, not extraneous, so I'm good to box it. Okay, next example. 4 times the cube root of 2x plus 1 equals 12. So I need to divide both sides by 4 to isolate that radical. So I get cube root of 2x plus 1 equals 3. So then, of course, I'm going to raise both sides to the third power since that's my index. So I have 2x plus 1 equals 3 to the third. So that's 27. And then I'm going to subtract 1, subtract 1. I get 2x equals 26. Divide by 2, divide by 2, I get x equals 13. And again, before I completely box and say that's the answer, let's make sure it's not extraneous. Let's plug back in. So 13 here would be 2 times 13, which is 26, plus 1 would be 27. The cube root of 27 is 3, and it's being multiplied by 4. 3 times 4 is 12, so this, in fact, does check out. So it's nice when the answers and the problems are easy enough to where you can check mentally. We will, of course, get to some that you can't check mentally. So number 4, look at the way this looks different from the previous problems. So all of the previous problems had radicals. This has a rational exponent, meaning a ratio or a fraction for an exponent. However, remember, based on what we learned in our rational exponent unit, you know that this really means this can be rewritten as the cube root. Remember that? It becomes the index, the denominator becomes the index of the quantity x minus 3 squared equals 4. Okay? And then, of course, the radical is already isolated. So we will go ahead and cube both sides. So then I get the quantity x minus 3 squared because the cube root and the cube cancel. 4 cubed is 64. Then, of course, to get rid of the square, you will square root both sides. So remember, when you square root this square, this becomes the absolute value of x minus 3 equals 8. Okay, and to get rid of the absolute value, you get x minus 3 equals plus or minus 8. So really you get x minus 3 equals 8. X minus 3 equals negative 8. So add 3, and you get x equals 11. And add 3, you get x equals negative 5. And of course you would want to plug in and check. But before we talk about that, I want to talk about an easier way than just doing this. So, but you will need to remember the basics of this, but there is an easier way. So let's take the original problem, which was x minus 3, the quantity x minus 3 to the 2/3 power equals 4. And instead, to solve it an easier way, you could just technically raise both sides to the reciprocal power. So the reciprocal of 2/3 is 3/2. Why do we raise to the reciprocal power? Raise to recip power. So this is like another way to solve. So another way to solve is to raise both sides to reciprocal power. So the reciprocal of 2/3 is 3/2. And remember, the reason that this is a better, easier, quote unquote, way is because when you have a power to a power, what operation do you perform to those powers? It's multiply. So what happens when you multiply 2/3 times 3/2? Of course, it turns to 1. So you have x minus 3 raised to the first power equals, well, here's the deal. Let's convert this 4 to 2 squared, right? Don't you agree with me that 4 is 2 squared? So we have 2 squared raised to the 3/2 power. And then again, I'm going to drag down the left. X minus 3 here equals, and then what happens when you have power to power? Well, you multiply. And what happens when you multiply 2/1 times 3/2? Hopefully you know that that would just equal 3/1 or 3. So really this is 2 to the 3rd, which really is 8. But while we take away this first power here and go to the next level, and this is 8, let's remember that this is plus or minus. Okay, so right here we're going to make a note. If you use this other easier way, then you have to remember to use plus or minus because the denominator of 2, this over here, whenever you raise that denominator of 2, indicates square root. So since you took the square root, remember that indicates that you need to do the plus or minus because of the absolute value bars that you saw over here. So don't forget, whenever you do the square root of a square, something like this, or you square root something and something comes out and it's an odd power, that you're going to get absolute value bars and you have the plus or minus. So if you use the easier way, just remember that only when you have an even denominator, if you have an even denominator like 2 or 4 or 6 that you raise the power to, the part that you do, not the original problem, but the part that you do, that you have to have a plus minus on your answer, which of course is the same answer we would have gotten here. Okay, so there's that. And remember, you should check your answers. So I'm not going to show this check. You could do it in your calculator. I don't have room to show it. I promise both of these work out, so I'm going to box them. But I will show you on the next problem where I have room off to the side how to check without a calculator. So these you could check with a calculator. You could plug in 11 here in the calculator, raise the quantity 11 minus 3, raise it to the alpha y equals 2/3 power, and you can see that the answer is 4 as it should be. And then I'm going to go back up and copy and paste. And instead of plugging in 11, I'm going to plug in -5 and hope that I get the same answer of 4. Oh, yes, I do. So I'm good to go. Okay, so that was in the calculator. All right, so now we're going to do this problem with this rational exponent the same easy way that we did before in Let's Talk. So of course you've got to isolate this first, the quote-unquote radical. So -1 minus 1. So we get the quantity, or excuse me, 3 times the quantity x plus 2 raised to the 3/4 power equals 24. Then we're going to divide by 3, divide by 3. So that becomes 1. And we have the quantity x plus 2 raised to the 3/4 equals 8. And then, of course, we will raise both sides to the reciprocal power. The reciprocal would be the 4/3 power. And let's talk. So, of course, that will multiply because that's our rule when we have power to power. So we'd have x plus 2 raised to the 1st. Okay, because 3/4 times 4/3 is 1. And then here we're going to do like we did previous. So I'm going to convert this 8 to 2 to the 3rd. You should know that, y'all. You should know that 8 is 2 to the 3rd, and it's being raised to the 4/3. Again, we have power to power. So that's like 3/1 times 4/3. So of course that equals 4/1. So we would have the quantity x plus 2 raised to the 1st equals, we said that when you multiply those it equals 4, so 2 to the 4th. 2 to the 4th equals 16. Okay, so you should know that as well. I took away the quantity to the 1st power because it equals x plus 2. Did I need absolute value bars? Do I need plus or minus? So the answer to your question is no plus or minus, because no absolute value bars, because raised both sides to an odd denominator. Okay, so we raise both sides to an odd denominator, not an even denominator like before. So no plus or minus, no absolute value bars. So this will produce only one answer. So -2, -2. And of course we get x equals 14. Okay, so before I box, let's check. And these are some of the ones that you can't check mentally probably, because I bet you don't know what 16 raised to the 3/4 is off the top of your head. So we're going to show it off to the side. Well, let me get a different color. Okay, so I have the original problem, 3, the quantity, x is going to become 14. 14 plus 2 raised to the 3/4 power plus 1 should equal 25. Remember, I'm going to draw this line down, and I'm going to go all the way down, and this side always has to stay the same. Okay, so here and here we get, following PEMDAS, 14 plus 2 is 16. 16 raised to the 3/4 plus 1. So again, you should know that 16 is 2 to the 4th power. We just talked about that over here. Raised to the 3/4 power plus 1. So here when we have power to power, 4 times 3/4 is 3. So this is 2 raised to the 3rd power plus 1, because that becomes 3. So again, following PEMDAS, have to do PEMDAS. This would be 3 times 8. 2 to the 3rd is 8 plus 1. 3 times 8 is 24. 24 plus 1 certainly equals 25. So this is not an extraneous solution. We are good to go. Okay, I have one more quick thing I want to talk to you about. Let's go ahead and do it on the back real quick. So this is example number 6. I'm not going to go through it all with you, but I do want you to see this. 3/2 plus 4 equals -23. So to be honest, you don't really need to write this down. I just need you to know it. So practicing solving this problem, -4 minus 4, agreed. So then -x plus 6 to the 3/2 power equals -27. This is all I wanted you to see. That negative out there has to go away. So divide both sides by -1. You get positive quantity x plus 6 raised to the 3/2 equals 27. So then you would do the steps that you're familiar with.